Hi everyone. Let's start paper 4 of A2 Chemistry, May-June 2024, variance 41. In the first question, examiner is looking for the trend in the solubility of hydroxides of magnesium, calcium, and strontium. Explain your answer. So let me explain first. Down the trend, solubility of hydroxides of group 2 elements increases because down the trend, both lattice energy and hydration enthalpy decreases. Since in this scenario, lattice energy play a key role, which is why lattice energy decreases more significantly than hydration. Hence, standard enthalpy change of solution becomes exothermic. Okay. आप more exothermic भी कह सकते हैं. On the basis of that, जो least soluble है वो magnesium होगा, जो most soluble है वो strontium होगा, I have to write the name because examiner ने symbol दिया नहीं है. Magnesium, strontium, and then calcium. Okay. Next, suggest the variation in the pH of a saturated solution of the hydroxides of magnesium, calcium, and strontium. Explain your answer. So for 1 mark, I think सबसे पहले तो concept clear होना चाहिए. So let me try to clear the concept so that मैं उस explanation को लिख के भी दिखाऊं आपको. Let's do one thing. मैं यहाँ कुछ samples ले लेता हूँ. Concentration of hydroxide ions के. Let's suppose ये है 0.01. और ये है 0.02. राइट, मैंने से 2 सैंपल लिए हैं ट्रेंड डिटरमिन करने के लिए. अगर मैं यहां से POH की वैल्यू डिटरमिन करूं, जिसका फॉर्मूला आप जानते हैं, तो ये है -log OH नेगेटिव आइन. अगर मैं वैल्यू प्लग इन कर देता हूं, इस जगह पर मैं 0.01 लगता हूं, नेगेटिव लॉग लेता हूं, तो नेगेटिव लॉग 0.01 इज गोइंग टू बी 2. सो यहां पर मेरे पास POH की वैल्यू आ रही है 2. ओके. एक फॉर्मूला मैंने आपके साथ शेयर किया था, अगर आपको याद हो, pH प्लस POH इक्वल्स टू 14. तो अगर मैं ये 2 यहां पर प्लग इन करता हूं, तो मेरे पास pH की वैल्यू आ जाएगी 12. आई होप इट मेक्स सेंस टू यू. यानी जब आपके पास हाइड्रोक्साइड की कंसंट्रेशन 0.01 थी, तो pH आपके पास 12 थी. बिल्कुल इसी तरह से मैं 0.02 पे भी ये कॉन्सेप्ट अप्लाई करता हूं. सो मुझे यहां से POH की वैल्यू मिल जाएगी नेगेटिव लॉग 0.02 करूंगा तो 1.69। तो अगर मैं 1.69 ले रहा हूं और मैं सेम फॉर्मूला अप्लाई करूं तो मुझे यहां से पीएच कितनी मिलेगी? 14 माइनस दिस, आंसर इज 12.3। सही है ना? सो टेक्निकली हो क्या रहा है? हो ये रहा है कि जब कॉन्सेंट्रेशन ऑफ हाइड्रो ऑक्साइड आयन इंक्रीज होगी तो पीएच वैल्यू भी इंक्रीज होगी। ऑलराइट, ये याद रखिएगा। ठीक है, तो कंक्लूजन ये है, डाउन द ग्रुप solubility of hydroxides increases if solubility of hydroxide increases, so concentration of hydroxide ions also increases. If concentration of hydroxide ion increases, pH value also increases. Okay, I hope it makes sense to you. Next is barium hydroxide is a strong base. Strong base means fully dissociate होगा in aqueous medium, ionizes fully in aqueous medium. 250 cm cube of barium hydroxide with a pH value 12.2. Calculate the mass of barium hydroxide required. Show your working. Okay. So first of all, in the first step, we have a relationship pH plus POH equals to 14. We know the pH value. Okay. So from this pH value, I can find the POH value. So POH is basically 14 minus 12.2. So it's basically 1.8. All right. Now from POH, and by using this expression, I can find the value of concentration of hydroxide ions. So 1.8 equals to minus log concentration of hydroxide ion. So hydroxide ion की concentration is going to be shift log minus 1.8 is going to be 0.0158 4 mole per dm cube. ये concentration 1000 cm cube में है. So 1000 cm cube of hydroxide ion contain 0.01584 moles. So हमें क्वेश्चन के अंदर 250 cm cube वॉल्यूम दिया था. So let's talk about in 250 cm cube how much ions we have. So it's 250 into or divided by 1000. So it's going to be moles of hydroxide would be 3.962 into 10 to the power minus 3 moles. See, barium hydroxide and hydroxide ion, both of them have 1:2 ka ratio. This is 1 mole, this is 2 mole. If you have calculated 3.962 into 10 to the power minus 3 moles, so how much amount we have? So moles of barium hydroxide divided by 2 So I'll get 1.98 into 10 to the power minus 3 moles. So examiner ने मुझे barium hydroxide का MR शो किया है. So in order to calculate the mass, (1.98 into 10 to the power minus 3 into 171.3 into 171.3. So it's 0.3393 gram. So that's the answer. 0.3393 gram. Okay. ठीक है. Next is the solubility of iron 3 hydroxide FeOH taken 2 is this. Yani concentration of iron 2 hydroxide is given. That's important. Concentration is given. We need the expression for KSP of this. First of all, you should know when iron 2 hydroxide ionizes, it will turn to iron 2 ions and 2 hydroxide ions. On the basis of that, the expression of KSP would be like this. Concentration of iron 2 ions, concentration of hydroxide ions. Since we have 2 mole in the equation, these moles needs to be in the power. Okay. Calculate the value of KSP of this. So first of all, let me make the equation. FeOH taken 2 iron 2 ions and hydroxide ions has 2 moles, right? Remember one thing, we have 1:1 का ratio between them. So अगर हमारे पास 5.85 into 10 to the power minus 6 mole per dm cube है, तो concentration of iron ions भी same होगा. That is 5.85 into 10 to the power minus 6 molar. Molar means mole per dm cube. Now we know that these two substances have 1:2 का ratio. So amount of hydroxide ion would be twice of iron 2 hydroxide. So 5.85 into 10 to the power minus 6 multiplied by 2 because we have 2 moles, right? So 5.85 exponent minus 5 into 2 or minus 6 into 2. So it's going to be 1.17 into 10 to the power minus 5 molar. So I know the concentration of iron 2 ions and hydroxide ion. So plug in these two values in this expression and you will get your answer. This is the first part and this is the second part. Kp equals to concentration of iron 2 ions, concentration of hydroxide ions, power square. Iron 2 ions has a concentration of 5.85 into 10 to the power minus 6. Hydroxide ion की concentration is 1.17 into 10 to the power minus 5 and then square. So अगर मैं इसको multiply कर दूं 5.85 exponent minus 6 से, तो it's going to be have I done some mistake? 5.85 into 10 to the power minus 6. 5.85 exponent minus 6 times 2. So it's 1.17 into 10 to the power minus 5 into 1.17 exponent minus 5 into 5.85 exponent minus 6. So it's going to be 8.00 into 10 to the power minus 16. And the unit is going to be mole cube dm minus 9. We have discussed such units calculation in the class, right? So it's going to be 8.00 into 10 to the power minus 16. Unit is mole cube dm minus 9 because it has mole per dm cube. It also has mole per d cube. Because of a square, it's going to be mole cube dm minus 6. So when units multiply होती है तो power add हो जाती है, so it's going to be mole cube dm minus 9. Okay. Question number 2. Define transition element. An element which can form one or more stable ion having partially filled d orbital is called transition element. Why transition elements can form complex ions? Due to the availability of empty d orbital. So due to the availability of these empty d orbitals, ligands can donate their lone pair also. Because these orbitals have close proximity of energy. The 3d orbitals in isolated silver ions are degenerate. Define degenerate d orbital. Degenerate d orbital means equal energy orbitals. Sketch the shape of 3dxy orbital. So I've told you in variance 42 that d subshell has 5 orbital. The first one is dxy, the second one is dxz, the third one is dyz. These 3 orbitals always exist between the axes. So x and y. So it has to be like this. तो आप नोट करें, these orbitals exist between x and y. Okay. Tollens reagent is basically a weak oxidizing agent, can be used to distinguish between aldehydes and ketones. Tollens reagent contain ammonical silver hydroxide, which can be prepared in the two-step process. Aqueous NaOH is added dropwise to aqueous silver nitrate to form silver oxide as a brown precipitate. Okay, and the second, construct equations for each step in the preparation of this complex. Okay, so first of all, we have silver nitrate. We are adding NaOH and we are converting silver oxide. Since we have 2 silver here, In question number 2, define transition element. An element which can form one or more stable ion having partially filled d orbital. Why transition elements forms complex ions? Due to the availability of empty orbitals which are available for bonding. The 3d orbitals in isolated silver ions are degenerate. Define degenerate d orbitals. Equal energy orbitals are degenerate d orbitals. Sketch the shape of 3dxy orbital. Well, this orbital exists between the axes. So what we can do is we have to make one lobe on the z-axis. My bad. And another lobe here. So these two lobes exist between x and y. Okay. Tollens reagent can be used to distinguish between aldehyde and ketone. Aqueous NaOH is added dropwise to aqueous silver nitrate to form Ag2O. Construct equation for each step in the preparation of this complex. Okay, so first of all, we have silver nitrate. I'm adding NaOH in it, converting into silver 1 oxide, which is a formula of Ag2O. Since we have two silver atoms here, so I'll put 2 here. We have 2 nitrates, so obviously it will combine with 2 sodium ions and convert it into 2 NaNO3. Total oxygen atom on the reactant side is 8. How come? Let's see. 2 times 3 6, 6 plus 2 8. And the total oxygen atom on the product side is 2 times 3 6, 6 plus 1 7. So 1 oxygen and 2 hydrogen left. They will combine together to give water. Now in step 2, aqueous ammonia is added dropwise to silver oxide. So we have silver oxide. We need to add ammonia, and ammonia is in excess. I mean in aqueous form, which means we need to add water molecule here. And obviously it will turn to a complex ion, which is AgNH3 taken to OH. Now we have 2 ammonia on the product side, so let's do balance. We have 2 silver atom on the reactant side. We need to put 2 here. So total ammonia would be after this 2 is 4. So मैं यहाँ पर 4 कर लेता हूँ. So silver balanced, ammonia balanced. Let's talk about hydrogen. We have 4 times 3, 12 hydrogen, 12 plus 2, 14. We have 3 times 2, 6, 6 plus 2, 12, 12 plus 2, 14. So it's balanced, I believe. It's a balanced chemical equation. Okay. I hope it makes sense to you. Name the shape of the complex ion this. Let me draw the shape of this diamine silver 1 ion. This is the structure of diamine silver 1 ion. See, examiner is looking for the bond angle of this H and G angle. H and G angle. H and G angle. That means examiner is looking for this sort of angle. So around nitrogen atom, we have 4 bonds and 0 lone pair, which means its bond angle is going to be 109.5 degree. And around this, we have 180 degree angle. And this complex has a linear geometry because of sp hybridization. All right. So an electrochemical cell uses silver oxide as the positive electrode and zinc as the negative electrode immersed in an alkaline electrolyte. So alkaline electrolyte means that electrolyte contain hydroxide ion. Okay. The overall cell reaction is shown, which means silver oxide is converted into silver atom in an alkaline medium. Zinc is converted into zinc hydroxide in an alkaline medium. An examiner is looking for the half cell equation, which we need to be completed. Okay, so that's an easy thing. Silver oxide is converting into silver. We have 2 silver here, put 2 here, and obviously it has to be in the alkaline medium, right? We have 1 oxygen here, so I'll put hydroxide ions here. We have 2 minus charge here, so to balance the charge, I will use 2 electrons here. How much hydrogen atoms here? Okay, so I'll use water. So let me check. We have 2 oxygen, we have 2 oxygen, we have 2 hydrogen, we have 2 hydrogen, we have 2 silver, we have 2 silver, we have 2 minus charge, we have 2 minus charge. So it's balanced. Okay. Zinc is converting into zinc hydroxide. And obviously the medium should be an alkaline medium. If the charge is 2 minus here, so obviously charge has to be 2 minus here. Let me check क्या balance हुई है equation या नहीं. These 2 hydroxide cancel out with each other. These 2 electrons cancel out with each other. So the final equation has to be like this. So it's a balanced chemical equation, correct equation. Okay. Next, coordination polymers. That's tricky part. Coordination polymers are very complicated sort of structures. Okay. Usually they don't ask such question in A2, but इस paper में पूछ रहे हैं वो. When bidentate ligand acts as a bridge, bidentate ligand acts as a bridge between different metal ions. That's very, very important aspect of this part of the question. Okay, let's move on to the next one. Under certain condition, Ru3 plus and a bidentate ligand DPS forms a coordination polymer. Oh my goodness, that's a coordination polymer containing this and chains. ये DPS का पॉलीमर है. It's a bidentate ligand जिसको उसने शॉर्टकट से इस तरह से रिप्रेजेंट किया है. Examiner is basically looking for the structure in which this bidentate ligand DPS uses each nitrogen atom to bond different Ru3 plus ruthenium atom कहते हैं उसको, ruthenium ion. Complete figure 2.3 by drawing the structure of the coordination polymer show 2 repeating units. The DPS ligand can be represented using this. Okay. What we can write it here, कि हम इसको copy करते हैं एक मरतबा और हम इसको लिख लेते हैं एक मरतबा और. My goodness, that's a huge structure. सही है. और जो बाइडेंटेड ligand है वो ब्रिज का काम करेगा यहाँ पर between different metal ions. So what we can do is कि मैं इस तरह से लिख सकता हूँ, ये एक बाइडेंटेड ligand है, ये एक बाइडेंटेड ligand है जो कि दोनों मेटल आयन को ब्रिज कर रहा है. ठीक है. इसी तरह से एक और नाइट्रोजन एटम होगा, वो इसको ब्रिज करेगा. ओके. और यहाँ पर भी एक नाइट्रोजन एटम होगा जो कि इसको ब्रिज कर रहा होगा. वी नीड टू मेंशन 4 क्लोरीन एटम्स. सो 1 2 3 4 1 2 3 and this 4. okay. सो 2 रिपीटिंग यूनिट्स कह रहे थे एग्जामिनर हमसे. इसका मतलब हमें ये जो ब्रिज है ये दोबारा से बना के देना है एग्जामिनर को. ये हमने एक ही बनाया, इट हैज टू बी 2. ये आ जाएगा. सही है. आई होप इट मेक्स सेंस टू यू कि ये 2 रिपीटिंग यूनिट्स हो गए. ये एक रिपीटिंग यूनिट हो गया, ये दूसरा रिपीटिंग यूनिट हो गया. ओके. Is there any possibility? No, that's the only possibility left. Okay, next, move on to the next question. Sample of hydrated lithium ethanedioate is gently heated. 2 gaseous products are formed and a white solid residue remain. The residue is added to silver nitrate. A gas is produced that turns lime water milky. By the way, this shows carbon dioxide. और अगर कार्बन डाइऑक्साइड मिल रहा है तो इसका मतलब this residue is basically lithium carbonate, which is why when it is treated with nitric acid, carbon dioxide gas is given off. So complete the equation. So obviously lithium carbonate is formed along with 2 gases. The first gas is carbon dioxide and the second gas is water. Let's balance the carbon atom here. 2 carbon atom, 1 and 2 carbon atom, 4 oxygen atom and 1 5. So 2 and 3 5. Oh, oxygen to balance नहीं हुई. Oh, 3 and 2 5, 5 and 1 6, 2 hydrogen, 2 hydrogen. So ये कैसे balance होगी फिर? Oh, that means कि ये कार्बन डाइऑक्साइड नहीं हो सकती, कार्बन मोनोऑक्साइड होगी क्योंकि कार्बन डाइऑक्साइड तो डिकम्पोजिशन के बाद मिल रही है ना. So it has to be carbon monoxide. Let's check now. 3 1. Okay, so suggest which of calcium ethanedioate or barium ethanedioate will decompose at a lower temperature. The higher the charge density, the stronger the polarization, the easier the decomposition. All right, that's the whole concept. So what we can write here is calcium ion has a smaller ionic radii than barium ions. So it has high charge density. Calcium ion has a strong polarizing power. then barium ions. So it distort the electrons of C2O42 negative ion easily. Hence, calcium ethanedioate decomposes at lower temperature. Potassium iron 3 ethanedioate dissolves in water to form a green solution. Explain why transition elements forms colored compounds. Well, colors of transition element depends on the strength of ligand. Transition metal complexes depends on the strength of ligand and DD electronic transition. Okay. So this ligand splits degenerate d orbital into two different sets of groups. Between these two groups, electron promotion takes place, due to which its complementary color is observed. The anhydrous iron 3 compounds decomposes on heating to form a mixture of this compound, and carbon dioxide. Complete the equation for the decomposition. Complete the equation. Okay. So how many potassium here? 3. How many potassium here? 4. So इसका मतलब potassium को balance करना है. I'll put 2 potassium here. So total potassium would be 6. In order to balance, I'll put 2 here. So ये 2 times 2 कितने हो जाएंगे? 4 potassium and 2, 6 potassium balanced. Iron हमारे पास कितने हो जाएंगे? 2. Iron हमारे पास कितने हो जाएंगे यहाँ पर? 2. Iron balanced. So 3 times 2, 6, 6 times 2, 12 carbon atom. So 2 times 2, 4, 4 times 2, 8, 8 plus 2, 10, and 12 करने के लिए यहाँ पर 2 लगाइए, and I believe oxygen is balanced. Let's count oxygen. 3 times 4, 12, 12 times 2, 24. So 2 times 4, 8, 8 times 2, 16, 16 times 4, 20, 20 times 4, 24. The equation is balanced now. आप चाहें तो यहाँ 1 लिख सकते हैं. Next is this iron complex ion shows stereoisomerism. Complete the 3-dimensional diagram to show the 2 stereoisomers of this complex. This ligand can be represented by this. By the way, we have done this in class also, if you remember. Let me draw the 3-dimensional structure first. Okay, I've told you in the class, we have discussed this in class. Whenever we have three bidentate ligands, obviously optical isomerism exists. This is the first, this is the second, this one is third. इसका mirror image कुछ ऐसे बनेगा. All right, we have done this in class. Buffer solution are used to regulate pH. Write two equations to describe how a solution containing HC2O4 minus ion acts as a buffer when small amount of acid or alkali is added. So when we add acid, obviously this ion is going to accept it, or accept this proton, and will turn to H2 C2O4, and that's your ethanedioic acid. Okay, but when alkali is added, it donates its proton and as a result C2O42 minus and water is formed. That's an easy sort of equations. A fuel cell is an electrochemical cell that can be used to generate electrical energy by using oxygen to oxidize fuel. Ethanedioic acid dissolves in an alkaline electrolyte is being investigated as a fuel. The relevant standard electrode potential for both the half cells are shown. Use these equations to deduce the overall cell reaction and calculate the E0 cell value. So as per my instructions, half cell with a more positive SEP value will write as it is in the form in the reduction form. So I will write it as it is in the reduction form. That means this equation needs to be written in oxidation form, and for that we need to flip the equation. Once if we flip the equation, we need to balance the number of electrons. Obviously, this equation has 2 electrons, this equation has 4, which means to balance the number of electrons, we need to multiply this equation by 2. As soon as the number of electrons are balanced, they will cancel out with each other. And the final equation would be like this: O2 plus 2C2O42 minus, that is ethanedioate ions, water, single arrow, 4CO2 plus 4 hydroxide ions. All right, that's the overall cell equation. Full cell equation भी कहते हैं इसको हम. Let's write this equation here. Oh my god. O2 plus 2 C2O42 negative plus 2H2O 4CO2 plus 4OH negative. All right, let me find out the value of E0 cell, which is also called cell potential or EMF. I'm going to use E0 right minus E0 formula. In E0 right, we need to plug in the more positive SEP value, which is 0.40 volt. In E0 left, we usually plug in the value with a less positive or a negative value. So I will write 0.59 volt here. So E0 cell becomes 0.99 volt. So plus 0.99 volt. All right. That's the end of question number 3. Let's start question number 4. Define a standard electrode potential, including the description of a standard condition. The potential difference when the test electrode is attached to standard hydrogen electrode measured under 1 atm pressure, 298 Kelvin, and 1 mole per dm cube electrolyte. Now the next is an electrochemical cell. Electrochemical cell is a cell in which chemical energy is converted into electrical energy, is used to measure the E naught of the silver half cell electrode. Draw the label diagram to this electrochemical cell. I can make the diagram, and we have discussed such things in the class, if you remember. This is going to be the standard hydrogen electrode. All right. It's your beaker. And this beaker contains electrolyte. That's your electrolyte. Okay. Again, it's a beaker and also contain an electrolyte. Both the half cells are connected by a salt bridge, and this salt bridge is used to maintain the electrical neutrality in both the half cell. All right. So this is going to be your voltmeter. Voltmeter is also called potentiometer. This is going to be your silver electrode. And obviously, this electrolyte contains silver ions. Examiner is saying that we don't need to mention the state conditions. This silver ion has a concentration of 1 mole per dm cube, which is also called molar. That's your salt bridge. From here, we need to introduce hydrogen gas at 1 atm pressure under 298 Kelvin. That is going to be your electrolyte, which is 1 mole per dm cube hydrogen ion. All right, that is going to be your platinum electrode. Platinum is a metal. It contains C of mobile electron, so it has a good electrical conductivity. And second reason for using this electrode is it is unaffected by most of the acids. All right, so it is chemically inert. By the way, this is going to be the positive half cell. This is going to be the negative half cell. So I need to mention the terminals also. This is negative half cell. This is positive half cell. Electrons in the external circuit always flows from negative half cell to positive half cell. I hope it makes sense to you. All right, let's move on to the next part. A separate electrochemical cell is set up using lower concentration of silver ion than used in B1. Suggest how the electrode potential under non-standard condition for the silver ion electrode would change from its SEP value. Explain your answer. So first of all, let me write the equation. Silver ions will gain electron and convert it into silver metal. The standard electrode potential value for this half cell is 0.80 volt. All right. So we have calculated this value when the concentration of silver ion was 1 mole per dm cube. Since the concentration of silver ion is getting lower, which means equilibrium favors towards left hand side. If equilibrium favors towards left hand side, then obviously oxidation becomes favorable. If oxidation becomes favorable, then potential value becomes less positive or more negative. All right. As the concentration of silver ions decreases, favors equilibrium towards left hand side, as oxidation becomes favorable, so potential value becomes less positive or more negative. All right. Now define enthalpy change of solution. When 1 mole of compound is dissolved in large amount of water, to give an infinite dilute solution, under standard condition. एग्जामिनर ने लिखा नहीं है यहाँ, लेकिन यहाँ नोटेशन दी हुई है उसने स्टैंडर्ड कंडीशन की, इसलिए मैंने अंडर स्टैंडर्ड कंडीशन मेंशन कर दिया. All right, let's move on to the next part. My goodness, some relevant energy changes for silver nitrate are shown in table 4.1. Solution of silver nitrate is given, hydration and of silver ion and nitrate ion is given. Complete the energy cycle in figure 4.1 to show the relationship. Include state symbol for all the species. All right. Okay. So first of all, 1 mole of silver nitrate is converted into gaseous silver ion and gaseous nitrate ion. This is going to be the reverse of lattice energy, and the reverse of lattice energy is called lattice dissociation enthalpy, which is represented by minus Le. Now in the next part, this is going to be the hydration of cation, and cation is basically silver ion. So gaseous silver ion will turn to aqueous silver ion. Gaseous nitrate ion remain as it is. Now in the next stage, hydration of nitrate ions. So aqueous silver ions and gaseous nitrate will turn to aqueous nitrate ions. All right. One more thing. Since the standard enthalpy change of solution of silver nitrate is endothermic, which is why arrow needs to be upward. Like this. We have done that in class, if you remember. All right. ये पूरी साइकिल एज इट इज रहेगी. व्हाट वी कैन डू इज कि हम इस अपवर्ड एरो हमने बनाया लैटिस डिसोसिएशन एंथैल्पी का, वी कैन मेक इट लाइक दिस. आप रिवर्स एरो भी बना सकते हो, बट इट्स गोइंग टू बी लैटिस एनर्जी देन. ओके, फिर ये आएगा. इट डजंट मेक एनी डिफरेंस, सेम चीज है, बिल्कुल सेम बात है. Calculate the lattice energy of silver nitrate. Okay, I'm going to apply the formula. Standard enthalpy change of solution equals to minus Le plus enthalpy change of hydration. Solution, the value of solution is given, which is 22.6 minus lattice energy we need to find out plus hydration of silver ion 475 hydration of nitrate ion minus 314. So the value of lattice energy after the calculation is going to be after the calculation the value is going to be I don't know minus 811.6 minus 811.6 kilojoules per mole. Let me write value here minus 811.6. Okay. Part E suggests a trend in the magnitude of the lattice energies of metal nitrates, NaNO3, magnesium nitrate, and rubidium nitrate. First of all, magnesium has a high magnitude of charge, so it has high charge density, which is why it exhibits strong electrostatic attraction. So its lattice energy is most endothermic. Magnesium ion has a high charge density exhibits strong electrostatic attraction between ions, hence its lattice energy is most exothermic. So this is going to be magnesium nitrate. You know, both rubidium and sodium are found in the same group of the periodic table, which means both of them have same magnitude of charge. Obviously, if the charge is same, we'll look for the ionic radius. So the sodium ion has a smaller ionic radius, so it has high charge density than rubidium ion, which is why this compound exhibits a strong electrostatic attraction. So it has a strong ionic bond, which is why its lattice energy is greater than rubidium nitrate. And rubidium nitrate has the least lattice energy value, least exothermic. So what we can write here, sodium ion has a smaller ionic radii than rubidium ion. So sodium nitrate exhibits strong electrostatic attraction, hence its lattice energy is more exothermic than rubidium nitrate. So that's the end of this question, and we need to start question number 5. All right, let's start question number 5. In an aqueous solution, persulfate ions reacts with iodide ion as shown in the equation. We have done this equation in the class. The rate of reaction in 1 is investigated. Sample of persulfate ion is mixed with large excess of iodide ions of known concentration. So why are we taking large excess of iodide ion? To make the concentration constant. Okay. The figure in 5.1 shows the result obtained. Now, examiner is looking for the initial rate of reaction, and we need to mention the working. So what we can do is, let's draw the tangent from the initial value, which is from 0.8. Okay, that's the initial value. Since examiner is looking for the rate of reaction in minute inverse, which means we don't need to convert time into second, minutes into second. Okay, so rate is going to be how much? 0.8 divided by 50. So 0.8 divided by 50, 0.8 divided by 50, 0.016. Okay. The rate equation for reaction 1 is this, which means with respect to persulfate ion is first order. कोई number नहीं होता तो 1 लेते हैं. With respect to iodide ion, it is also first order. Suggest why large excess of iodide ions allows the rate constant to be determined. So obviously, to make the concentration remains constant throughout the experiment. So that we can find the rate constant easily. Okay. The reaction of persulfate ion and iodide ion is catalyzed by Fe2 plus. Write two equations to show how Fe2 plus catalyzes reaction 1. By the way, we have done this whole topic in the class, why a standard electrode potential value. Since nowadays standard electrode potential values are not given in the question, which means you need to memorize it or you need to make it via ion electron rules. So let me apply ion electron rules. Okay. This is S2O8 2 negative persulfate ion converting into sulfate ions. Yes, that's what you need to remember, that persulfate ion will turn to sulfate ion under this reaction. How many sulfur we have? 2. Put 2 here. So sulfur is balanced. We have 2 times 4, 8 oxygen. We have 8 oxygen, oxygen balance. We have 2 minus charge. We have 2 minus charge, charge balance. Now, this persulfate ion reacts with iron 2 ions. So obviously this iron 2 ions will turn to iron 3 ions. We need to balance the charge, and for that I will put 2 here and I will put 2 here. Look at this. 2 times 2, 4 plus, 4 plus and 2 minus, 2 plus. Right? Check this. 2 times 2, 4 minus, 2 times 3, 6 plus, 6 plus, and minus 2 becomes plus 2. Over here it is plus 2. Over here it is plus 2. So अगर आपको याद नहीं है तो आप इस तरह से अप्लाई कर लीजिए. ठीक है. Now in the second equation, this iron 3 ions is basically an oxidizing agent. Iodide ion is a reducing agent. So iron 3 ions oxidize iodide into iodine and obviously khud reduce hoga and will turn to iron 2 ions. Now we have 2 iodine here. So let's balance the equation here. Charge balance karna hai, to put 2 here and 2 here. Let's talk about the charge first. This is 2 times 3, 6 plus. This is 2 minus. So 6 plus and 2 minus, becomes 4 plus, right? Over here we have 4 plus. So it's balanced down. By the way, reaction start with iron 2 ions, at the end वापस iron 2 ions मिल रहे हैं, acts as a catalyst. Describe the effect of an increase in temperature on the rate constant. As temperature increases, rate constant also increases. In aqueous solution, thiosulfate ions reacts with hydrogen ion as shown in the equation. The rate of reaction is first order with respect to thiosulfate ion and zero order with respect to hydrogen ion, which means this has nothing to do with the rate of reaction. Iski concentration kam ho ya zyada ho, no impact on the order rate of reaction. The rate constant K for this reaction is given. Calculate the half-life. So since the reaction is first order, so in order to calculate the half-life for the first order reaction, I'm going to use this formula 0.693 over K. So 0.693 is basically ln2. 0.693, I repeat, is ln2. But 0.693 is basically the constant. I'm not going to change it. K key value is already given. K key value is given here. So I'm going to plug in this value here. 1.58 into 10 to the power minus 2. So the T half is going to be 43.9 seconds. Let me check one more time. 0.693 divided by 1.58 exponent minus 2. 43.86. So 43.86 means 43.9. Okay. The compound nitrosyl bromide can be formed shown in reaction 3. The rate is first order with respect to NO and first order with respect to bromine. If both of them have first order reaction, which means both of them are involved in the slow step reaction. The reaction mechanism has 2 steps. That's a very important point, very important aspect. Suggest equation for the 2 step of this mechanism, which is the rate determining step. Okay, so it's easy. NO is reacting with bromine, converting into NoBr2. Now this NoBr2 is basically an intermediate. So it will react with NO again and convert it into 2NoBr. As you can see, ये intermediate cancel हो जाएंगे आपस में. So you will get the equation, and that equation is exactly matches this one. ठीक है? Now bromine and NO both are involved in the slow step reaction because both of them are first order, which means step 1 is the slow step reaction. So that's the end of question number 5. Let's move on to the question number 6. Oh my goodness. State what is meant by partition coefficient. It is a ratio of the concentration of solute in 2 different solvent at equilibrium. All right. Partition coefficient KPC for compound X between carbon disulfide and water is this. So we know the KPC value. We know that 1.85 gram of X is dissolved in water. So we have an aqueous layer of water and made up to 100 cm cube in volumetric flask. So in 100 cm cube, we have 1.85 gram. If 40 cm cube of this water is shaken with 25 cm cube of CS2, the CS2 is basically the organic layer, water is basically the aqueous layer. and the mixture is left to reach equilibrium. Calculate the mass of X extracted in CS2 layer. Oh my goodness. We have multiple steps here. In the first step, 100 cm cube contain 1.85 gram of X. If we use 40 cm cube, how much mass we have? So mass of X is going to be 1.85 into 40 divided by 100 is going to be 0.74 gram. Whew. Now we have two different layers. The first one is aqueous and organic. So this is our second step. This is our organic layer. And this is our aqueous layer. I don't know how much amount is extracted into this into this organic layer. So let's suppose X gram is dissolved in 40 cm cube. Dissolve in 25 cm cube of CS2. So from this, I can find the concentration of compound X in organic layer, which would be X upon 25 gram per cm cube. Now we have that much mass of X, और उसमें से X gram जो है वो organic में dissolve हुआ. So in aqueous layer, 0.76 minus X gram is dissolved in 40 cm cube of X, 40 cm cube of water. So the concentration of compound X in aqueous layer would be 0.76 minus X divided by 40 gram per cm cube. So let me plug in these values. We know the partition coefficient value, which is 10.5. We know the concentration of compound X in organic layer, which is X over 25 divided by 0.76 minus X over 40. So the value of X from here would be 0.642 gram. So this is 0.642 gram. Okay. The compound C6H6 has many structural isomers. Four suggested structure of C6H6 are shown in figure. This is called Kekule, Dever, Ladenburg, and delocalized benzene. Using table 6.1 to predict the number of carbon atoms that have sp, sp2, and sp3 hybridization. By the way, we need to check hybridization in Kekule, Dever, and Ladenburg. Whenever triple bond between the carbon atom, we can have sp hybridization. When we have double bond between the carbon atom, sp2. When we have triple single bond between the carbon atom, we can have sp3. So in Kekule, we have sp2 hybridized carbons because of the presence of double bond. So Kekule, we have 6 sp2. There is no sp, there is no sp3. All right. Now look at these 4 carbon atoms. These are double bonded carbon atoms, which means these carbon are sp2 hybridized, which means sp2 hybridized are 4, whereas these 2 carbon are single bonded carbons, which means ये 2 sp3 hybridized and 4 sp2. Ladenburg, all of them are single bonded carbon atom, which means all of them are sp3 hybridized. No sp2, no sp. That's an easy task. That's an easy thing. Remember one more time. sp3 hybridization means single bond, sp2 means double bond, and sp means triple bond. Okay. Describe the shape of delocalized benzene. So benzene has hexagonal ring shape. Okay. Include the geometry of each carbon atom. All carbon are sp2 hybridized because of the double bond, and so they are planar or trigonal planar. Examiner is looking for the bond angle with an angle of 120 degree. Next, all types of bonds between carbon atoms. So between carbon, we have sigma bond and pi bonds. Sigma bonds are formed through head-on overlapping of orbital. Pi bonds are formed through sidewise or lateral overlapping of p orbital. Okay. Next, carbon and hydrogen atoms. Okay. So between carbon and hydrogen, we can have only sigma bond. Suggest why benzene and benzene are unstable isomers of C6H6. Look at the structure of both the compounds. These structures are very compact and rigid. And because of rigidness and compactness, they will experience bond pair repulsion. And because of that repulsion, molecules are going to collapse and cannot exist. Since both the structures are compact and rigid, so they will experience repulsion. Between bond pairs. Bond pairs also called single bond. Complete table 6.2. Predict the number of peaks in the proton NMR spectrum for benzene, Ladenburg benzene, and delocalized benzene. They were Ladenburg delocalized. And proton NMR. Okay, let's talk about proton. They were Ladenburg. Proton NMR. Ek hydrogen. We have one hydrogen here, one hydrogen here, one hydrogen here, one hydrogen here. So technically, these hydrogens are bonded with a double bond, which means these hydrogens have same chemical environment. Whereas this is single bonded carbon atom, one hydrogen here, one hydrogen here, and obviously these two hydrogens have different chemical environment, right? So these four hydrogen have same environment, while these two hydrogens have different. So in general, we have total two chemical environment in this compound. So I'll get two peaks. Okay. Let's talk about Ladenburg. Now we have one hydrogen here, one here, one here, one here, one here, and one here. And all these hydrogens have same chemical environment, which is why Ladenburg benzene has only one chemical environment in proton NMR. Let's talk about benzene. When all the carbon atom have one hydrogen and all of them have same chemical environment, which means they will have one chemical environment also. Next, for the reaction of phenylethanol with 1,4-dibromo butane in the presence of FeBr3 is shown in the figure. Okay, the mechanism of this reaction is similar to that of alkylation of benzene. Construct the equation for the formation of electrophile. That's the thing. This is the reagent. This is the catalyst. They will react together. My God. Br. So obviously this react with this. Now these two species react together to give FeBr4 negative, and obviously you will get your electrophile, which is going to be like this: Pr, CH2, 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 and CH2 plus. Now this electrophile is going to react with this compound, and for that we need to mention all the curly arrows, charges, and organic intermediate. Okay, so we need to complete the mechanism. That's an easy thing. Pi bond reacts with this electron deficient carbon, and as a result pi complex is formed. एक हाइड्रोजन यहाँ शो करो, 1, 2, 3, 4 and this Br. इस कार्बन को छोड़ के बाकी तमाम कार्बन्स को डॉटेड लाइन पॉजिटिव चार्ज से रिप्रेजेंट करेंगे as per instructions, as per format. This is going to be your pi complex. Now to remove this positive charge, this bond shifts into the benzene ring. Hydrogen moves in the form of hydrogen ion, and that's your product. Okay. Now in the next part of the question, the reaction shown figure 6.2 forms a small amount of two byproducts Y and Z. Suggest a structure for Y and Z in the small. Okay, two byproducts in a very small amount. Okay. Do one thing. First of all, this compound reacts with FeBr3 again and forms FeBr4 negative, and obviously you will get an electrophile now, and this electrophile has to be like this. Two, three, four. 1, 2, 3, 4. 1, 2, 3, 4, and this is going to be the positive charge. Okay, this is going to be your electrophile. Now this electrophile reacts with, this is my first step, this is my second step. That's tricky. That's not an easy part. See, it will react with this, and as a result pi complex is formed. And after the removal of hydrogen ion and shifting of bond into the ring, I'll get the product, and the product has to be like this. It's going to be very lengthy if I'll do each and every step. So I'm not writing pi complex, you know how to write that. Instead, I'll write this product straight away. This is the product, okay? So first of all, this is okay, and this bond has to be like this. So let me arrange this value. Your first CH2, second, third, and this one is fourth, and Okay, 1 2 3. Oh my goodness. Okay, I hope so. मैंने कोई गलती नहीं की हो. ये अटैच होगा. So 1 2 3 and this one is 4. Okay, 1 2 3 4. Let me check the carbon atoms because carbon atom to count करें ना. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. How many carbon atoms we have? 20. One missing. One missing. Okay, okay, okay. Wait. 1 2 3 4, and this one is. So let's attach this compound to this carbon atom. That's very tricky, very tough. I don't think so कि कोई भी कर सकता है इसको पेपर के अंदर within time limit. Let's check the carbon atom. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Carbon satisfied. 2 oxygen satisfied. Count hydrogen. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. 22 hydrogen, 2 oxygen satisfied. So that's the structure, guys. That is the structure. Okay. Let's talk about Z. For Z, let's do some working. And this is the structure. This bond. Then this CH2. Then this CH2. Then this CH2. And then this, or ye Br. CH2, 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 CH2. 1 2 3 4. Okay. Now what we can do is, we have one hydrogen atom here. So this hydrogen and this bromine combine together to give HBr. Because आप नोट करें जो फॉर्मूला है उसमें Br गिवन नहीं है, यहाँ पर भी Br गिवन नहीं था. इसका मतलब यहाँ से भी ब्रोमीन जा रहा है, यहाँ से भी ब्रोमीन जा रहा था. ओके, सो it has to be like this. This bond as it is, and this bond as it is. Okay. Now after this, I will write this bond, then this bond, and then this bond. Okay. Let's count the carbon atom. 1 2 3 4 5 6 7 8 9 10 11 12. 12 carbons. Yes, right. 14 hydrogens हैं. Let's count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and 1 oxygen. It's balanced. So that's the structure. That's the end of this question. Let's move on to the question number 7. 4 esters A, B, C, and D with the molecular formula C6H12O2 are shown in the figure. Give the systematic name of ester A. So आप सब जानते हो कि A में ये मिथाइल है और ये पेंटानोएट है. So compound का नाम is methyl pentanoate. Okay, a mixture of these esters is analyzed by gas liquid chromatography. The chromatogram produced shown in figure 7.2, the number of above each peak represents the area under the peak. The area under each peak is proportional to the mass of the respective ester in the molecule. इसका मतलब ये परसेंटेज बाय मासेस दिए हुए एग्जामिनर ने आपको. Examiner is looking for the definition of retention time, which we have discussed in the class. The time in which solute spends in the glass column from the point of injection to the point of detection. Determine the percentage by mass of ester D. So first of all, get the total area. So it's 14 plus 25 plus 52 plus 38. So I think it's 129. Confirm कर लेते हैं. Plus 25 plus 52 plus 38. 14, 25, 52, 38, 129. That's perfect. And I need to find the percentage by mass of D. So mass of D is 38 divided by 129 into 100. 38 divided by this into 100. So it's going to be 29.46%. Okay. Now the next part of the question is separate sample of esters are analyzed using proton and C13 NMR spectroscopy. Complete table 7.1 to show the number of peaks in each NMR spectrum of ester B and C. Ester B and C. तो सबसे पहले प्रोटॉन NMR की बात करते हैं. This will give you singlet because cannot apply n+1 rule. This will give you sextate because hold on, not sextate. We have 3 hydrogens here and 2 hydrogens here. So 3 plus 2, 5, 5 plus 1, 6. Yeah, I was right, sextate. Okay. This will give you duplet. Oh, no. Quantate. Because neighbor carbon atom has total 4 hydrogens. This will give you triplet. So how many peaks we have? 1, 2, 3, 4. 4 peaks. Let's talk about C. This will give you singlet. This will give you duplet because it has only 1 hydrogen in the neighbor carbon. This will give you multiplate because it has 8 hydrogen atoms in the neighbor carbon. So if you add 1 in it, you will get multiplate. And these two have same chemical environment, so they will give you duplet because they contain only 1 hydrogen in the neighbor carbon. How many peaks we have? 1, 2, 3, 4 peaks. So in proton NMR spectrum, both of them have 4 peaks, right? Oh, 1, 2. Oh, my bad. This also gives peak. Duplet because it has only 1 hydrogen in the neighbor carbon. So technically we have 1, 2, 3, 4, 5 peaks. You have to be very, very careful. Okay? 5 peaks. Now let's talk about carbon 13. This is the first carbon, this is second, this is third, this is fourth, this is fifth, this is sixth. So we have 6 chemical environment in ester B. Let's talk about C. This is first carbon, this is second carbon, this is third, this is fourth, and in dono carbon ka environment same, which means 1, 2, 3, 4, 5. 5 chemical environments in C13. Next, identify all the esters A, B, C, and D that have at least 1 triplet peak in their proton NMR spectrum. ट्रिपलेट बी, ये आपको ट्रिपलेट दे रहा है, सही है। ये नहीं दे रहा, ये भी नहीं देगा ट्रिपलेट, बिकॉज दिस कार्बन हैज नो हाइड्रोजन, दिस कार्बन गिव यू सिंगलेट, these three these 9 hydrogen have same chemical environment, so they will give you singlet again. Okay, this is the tertiary group, if you remember. So it will not give you triplet, it will not give you triplet. Obviously this will give you triplet. Look at this carbon, it has 2 hydrogen atom in the neighbor carbon, so it will give you triplet. So only A and B give you triplet. So just A and B. Okay. Oh god, oh my goodness, that's very analytical section of organic. Compound F C6H8O3 shows stereoisomerism and effervescence with sodium carbonate. If effervescence of sodium carbonate shows, that means CWH group is present. Okay, and stereoisomerism means either geometrical or optical. Now this compound F reacts with alkaline aquacidine, then you will get yellow precipitate of G and compound H. That means this compound F either contain CH3CO group or either contains CH3 CHOH group. Okay. Now in the next part, compound F reacts with lithium aluminum hydride to form compound J. Compound F reacts with thionyl chloride to give compound this. Compound K when react with propane 2-ol. By the way, propane 2-ol का formula ये होता है, याद होना चाहिए. You have done this with me in A1. This is propane 2-ol. Draw the structure of compound F. Okay. First of all, we have 6 carbon atom. So this is CH3, CO, okay, CH2, C, C, CWH. Let's first of all let's calculate this carbon atom. 1, 2, 3, 4, 5, 6 carbon satisfied. This group is satisfied, so it will give you yellow precipitates. All right. Now CWH is satisfied. How many hydrogen atoms? 3, 5, and 1, 6. And how many hydrogen atoms here? 8. So 2 hydrogen left, right? So if 2 hydrogen left, इसका मतलब एक यहाँ होगा, एक यहाँ होगा, और इन दोनों के दरमियान double bond होगा. And check, this will show you geometrical isomerism, because if 2 similar groups present on the same side of the double bonded carbon atom, you will get cis. जहाँ cis होता है वहाँ trans भी होता है. Okay. So this will give you CHI3, and this entire thing will turn to salt of carboxylic acid because the medium is alkaline. CWNA, that's salt. CH2, CH double bond CH, and then COONA. Okay. When this compound is treated with thionyl chloride, obviously only carboxylic functional group will react and turn to acyl halide. Baki molecule as it is रहेगा. CH3, CO, CH2, CH, double bond CH, and then COCl. Hence, satisfy the formula. When lithium aluminum hydride is a strong reducing agent, so it reduces carboxylic acid into primary alcohol and ketone into secondary alcohol. Alkene never react with lithium aluminum hydride. We haven't done any sort of any reaction in A1, right? So when this compound and this compound react together, you will get an ester. Why? Because acyl halide, when treated with alcohol, always an ester is formed. CO। अब क्या होगा, अब होगा ये कि यहां से H और यहां से Cl दोनों मिलकर बना लेंगे HCl, और ये बॉन्डिंग होगी ऑक्सीजन के साथ। अब इस ऑक्सीजन के साथ CH, दिस CH has two CH3, एक यहां लिखिए, एक यहां लिखिए, and that's your ester, and that's the end of question number 7. Let's move on to the next question. God. Oh. Neotame is an artificial sweetener added to some foods. Uh, State the number of chiral carbon atoms. So first chiral is this, and second chiral is this. We have only two chiral carbon atoms. Okay. Neotome contain the arene functional group. Identify all the other functional groups present in neotame. The first one is ester. The second one is amide, amine, carboxylic acid. Amine, in fact, secondary amine. Carboxylic acid. Amide. And ester. Neotame reacts with an excess of hot NaOH to form three organic products. State the two types of reaction occur when neotame reacts with hot NaOH. Since neotame has carboxylic functional group, so acid-base reaction takes place with NaOH, right? Also, neotame has amide and ester functional group, so they will undergo hydrolysis, all right? So they will hydrolyze as well. An examiner is looking for the three organic products in the next part of the question, most likely, because जब यहाँ कह दिया और वो पूछ नहीं रहे तो इसका मतलब next part में वो कह रहे थे. Look, draw the structure of the three organic products formed from the reaction of neotame with an excess of hot aqueous NaOH. So first of all, break the bond from here, break the bond from here, okay? CO will get OH of water, NH will get hydrogen of water. On the basis of that, the first structure is going to be like this. Got a lot of structures. This is NH. O, and this is going to be the salt because reaction होगा, और ये भी salt बनेगा carboxylic acid बनने के बाद, okay? So that's the salt. इससे next product बनाते हैं. This is going to be NH2 because NH will get hydrogen of water, and this is CO. CO will get OH of water, will turn to carboxylic acid. This acid will turn to salt because excess hot NaOH is used, okay? And my third product is CH3OH, that is methanol. The first product is methanol. Second product is this. Order कोई सा भी हो सकता है. And my third product is this. Okay. So that's the end of question, I think 7. Oh, question number 8. Let's move on to the next question. Question number 9. My God, question number 9 is basically related to phenol. Phenol has a formula of C6H5OH, reacts separately with sodium and with dilute nitric acid. Write the equation for the reaction of phenol with sodium. So that's easy. C6H5OH plus Na converting into hydrogen gas plus C6H5O Na. Let me balance the equation. Put 2 here, put 2 here, put 2 here. By the way, both of them, when treated together, react together. Reaction is going to be displacement reaction, sometimes redox reaction. Because sodium is oxidized into sodium ions, while hydrogen is reduced into hydrogen. Okay. Draw the structure of the two major isomeric organic products formed in the reaction when phenol reacts with dilute nitric acid. When phenol reacts with dilute nitric acid, obviously you will get ortho product and para product. This is going to be your ortho product and this is going to be your para product. And both of them are structural isomers of each other because both of them have same molecular formula but different structural formula. Okay. Salicylic acid can be synthesized from phenol. One of the steps in this synthesis is the electrophilic substitution reaction of carbon dioxide with phenoxide ion. Oh my God, phenoxide ion. Complete the mechanism between these two species. Relevant curly arrows, dipoles, and charges. Let's draw the structure of the organic intermediate. All right. First of all, both the oxygen are more electronegative elements, so has slight negative charge. Carbon has slight positive charge. Show the lone pair on the oxygen का charge. ये इसके साथ reaction करेगा at the same time pi bond shifts on the oxygen atom. When pi bond shifts on the oxygen atom, you will get what? You will get the structure. Ouch. Okay. Yeah, electrophilic substitution तो नहीं हुआ because examiner is looking for the electrophilic substitution reaction, right? I think so. It has to be like this. ये इसके साथ reaction करेगा because electrophilic substitution reaction always takes place through pi bond of benzene. At the same time, oxygen shifts on pi bond shifts on the oxygen atom, and so you will get what? You will get this structure. This is O negative. This is CO negative and double bond oxygen. और यहां से लेकर यहां तक pi complex. So इस स्ट्रक्चर में और इस स्ट्रक्चर में कोई फर्क नहीं है, ठीक है? ये मैंने वर्टिकली लिखा हुआ है, ये हॉरिजॉन्टली लिखा हुआ है. Oh yes, yes, one hydrogen is still there with the carbon atom, right? So to neutralize this positive charge, bond rings into the bond shifts into the ring, benzene ring, and hydrogen removes in the form of hydrogen ion, and that's the product. That's slightly tricky, slightly. Next, a lot of organic in this section, in this paper, in this variance. Some synthesis uses Diels-Alder reaction. My God, I did that in my master's. Diels-Alder reaction, very, very famous. Involves a diene and an alkene reacting together to form a cyclohexene. Draw 3 curly arrows in figure 9.4 to complete the mechanism for the Diels-Alder reaction between buta-1,3-diene and ethene. Oh, so what we can do is shift this bond between this carbon, shift here, at the same time shift there. So you will get this product, okay? I hope it makes sense to you. So जब ये वाला बॉन्ड यहां शिफ्ट होगा ना, तो मैं इसको रेड पेन से यहां बना देता हूं, ये रहा। सही। जब ये वाला बॉन्ड यहां शिफ्ट होगा तो मैं इसको रेड पेन से इस तरह से बना देता हूं। सही। बाकी तो सब कुछ आपके सामने। अच्छा, एक और भी चीज देख लीजिए, जब ये वाला पाई बॉन्ड यहां शिफ्ट होगा तो उसको मैं इस बॉन्ड से बना देता हूं। आई होप इट मेक सेंस टू यू। बाकी तो सारी चीजें सेम है, कन्वर्जन समझ में आ रही होगी, ओके? Another Diels-Alder reaction of buta-1,3-diene is shown in figure 9.5. Predict the product form. Same format. बॉन्ड यहां शिफ्ट कीजिए, बॉन्ड यहां शिफ्ट कीजिए, and shift the bond between here, right? So मैं पहले तो जो हमारा नॉर्मल स्ट्रक्चर है वो लिख के देते हैं। Oops. सही है भाई। So ये बॉन्ड यहां पर शिफ्ट होकर आ गया, ये वाला बॉन्ड यहां शिफ्ट हुआ है, और ये वाला बॉन्ड यहां शिफ्ट हुआ है, और ये जो बॉन्ड है ये वाला, ये एज इट इज, ये बॉन्ड एज इट इज, ये बॉन्ड एज इट इज, ये बॉन्ड एज इट इज, और ये बॉन्ड एज इट इज, और ये एज इट इज। आई होप इट मेक्स सेंस टू यू। दैट्स द स्ट्रक्चर गाइस। That's the end of this question. Let's move on to the next. Oh, that's the end of this paper.